Welcome back to Made Up of Wires, where we're decompiling Castlevania Symphony of the Night. If you're not familiar with the Castlevania Symphony of the Night decompilation project, you can go to soten.z.dev and learn more about it. I'm a contributor. I like to decompile, and I like Symphony of the Night. I've been working on been a contributor to the project for about a year and a quarter, not quite a year and a half. And I hope to be here till the end. We'll see. We've been working on Castle Keep, and I brought up yesterday that there was a function that decompiled and was pretty straightforward on the PlayStation, but was not matching on the PSP. And that was because there was a difference in not this one. There was a difference in the size to one of the structs that is opaque on the PSP, but it is opaque on the PlayStation in the PlayStation SDK. But when Konami was porting this over, they had to do tricks and other things like that to get it working on the PSP, and one of those was to re-implement a bunch of the SDK. And so we are trying to figure out how they did that as well. And a bunch of that is actually in the process of being decompiled, primarily by Gamester 81 or Gamester 81, Gamester and Zynamo, and they happened to come across something that I was just talking about yesterday, which was this DRM. And when I say it's an opaque structure, what that means is in the definition, we get something like this, where it's just a field of some size. And what we really need to know is what those fields are, but those are hidden. And C allows you to cast structs to different types, basically taking a pointer to that and casting it to a different type. And as long as the offsets all work out, everything is fine. But we can't do that necessarily on the PSP when the struct is different. So it was a different size, and this may be what was missing, and now it's in libgpu. So let's grab this and see if we can get this working. So this is somewhat interesting. This says the DRM is still size 40, but we really don't want 40. And what's nice though is we do have this struct now, and probably can pull out a mini version of it. That's what I originally called it, was the mini DRENV. And let's see if we can get this working. I'm not sure if we'll be able to do it completely, but we'll give it a shot. So the issue here was that when we're doing this copy down here on line 31, what we're copying is actually much larger than what is actually being copied in the original code. And whatever's on our stack is also much larger. And so our sp10 draw env variable there must be something different. At the beginning of draw env, is something that looks like this. And actually the way that this was done, no, they are different. This ends up sharing a significant number of fields. So I'm going to copy this. And we'll use that as a starting point. And we'll see if we can figure this out. Otherwise, we'll go back to the trigger function. That's the last one that is there. We're actually going to take this version of it and replace the one that's currently in the context. And I'm going to call this one DRENV Mini. Or Mini DRENV. And that will avoid the namespace clash. There actually was... That broke us a little more, but that's okay. We'll try to figure that out in a bit. And this SP10 field, now I'm going to make that mini DRENV instead. So we're going to have to do some casting down here, and that's okay. So down here, we're going to cast this as a mini DRENV pointer. We have to do it one more place. And then we need to cast it back when we are setting it down here. And this might not quite be right. It's possible that I'm going to run into problems, but we'll figure it out. Which bridge? This is the bridge. Hey, Mitri, good to have you. Mitri says this function handles some sort of bridge. Which bridge? I'll show you the bridge. Give me 1 second to get this compiling again, and then we'll go look at it. All right, so this does give us something that is different. Not necessarily in a good way. And part of that is because the size is too large for what we want to copy. I'm going to come back. So let's see. We're still at 3.4 versus 2C. Let's get rid of some of these fields and see how this... changes. No, maybe this wasn't what I was hoping it was. Okay. What bridge is this? We'll go do the trigger function next, and I'll... The bridge in question is the one in the clock tower. The clock tower has the gear section, which is what we think of normally. It has the pendulums, Karasaman, and this outer area. And this is the bridge specifically that we're talking about. I should be able to back up. And so this is any of these. There's a couple of these in this area. We can bat down there. So this bridge will collapse here. Oh, there it went. Let's see. There's at least, yeah, there's a couple over here. This one collapses. So it's any of those bridges. Oh, need focus. Can I get back? Yeah, there we go. Back too far. And now I'm stoned. Oh, that was lucky. All right, I'm going to pause it there. So those are the bridges we're talking about. It's likely that there are other... I'm trying to think of what other bridges collapse like that in the game. If you know, chat or comment if you're watching this later. Didn't want that, but I need a duck station button. I don't have a duck station button. So let me hide duck station again. So we were working on the bridge triggers, and if I can get my browser to work. I did, so Roaming mentioned, oh, did none of this save? How sad is that? I don't think any of this saved. All right, well, we have a PlayStation 1 version that's in flight. I should have the PSP version as well, even if it didn't save what was being worked on, at least the scratches there. So we're gonna see how close this is. I did do some additional work on the stream and got this a little bit closer, but we'll have to just redo that work, and that should be fine. Let's see, I'm gonna set a timer for myself, keep myself on task and on track. I think at this point I probably did come over to the PSP, and so we'll start here again and just kind of work down and fix things that I see along the way or that seem obvious. Going up or down through the assembly doesn't make a whole lot of difference. It's just whatever you prefer and however you like to work. And I like to jump around and do lots of different things. So occasionally I'll do that. So we're going to go top to bottom. On the left here, this is the assembly that we want to be producing. On the right is the assembly that we're currently producing. We have the C code that is producing that assembly, and then we can use M2C to get a automated decompile to get a rough idea of what that C code might have looked like. And so we're going to kind of flip between those things and see what we can see if we can get any closer. So starting with case 0 on line 28. Hey, don't fluff the pillows. So in the underground caverns, there's the ape skeleton bridge. Is there another one down there? So we see some stack pointer issues. No, we're not going to mess with those. As we remove variables, those should resolve themselves. Yeah, now that I remember what was going on, we have these loads for X and Y values from a global array. And then down here, we had a second load from tilemap and this slightly different function call. It's called boss door helper on the PSP. Let's go look at that. Interesting. I don't know where that symbol name came from, because it seems to be unique here. It is a function in the both the US and the PSP versions. So our break bridge function, I'm going to open this in the background because we do have that one. Just takes one argument. And so this happens occasionally. M2C will see that this value is stored in the A1 register. And so it doesn't know necessarily, if it doesn't have the function signature for break bridge, it doesn't know whether or not that should be part of that value should be an argument or not. And so we know now that it should not be an argument. Excuse me, hiccups. 46. There's an additional shift left, and I'm guessing it exists down here as well, and we're missing it down here. Yeah. So that means that the size may be wrong. So I made this an S vector. It might just be a vector. That's not correct. S vector has, and we need the sign extends, which is a hint that those are 16-bit ints as opposed to 32-bit ints. 190, let's look at where that is. So we're getting offset 2, and then we're shifting left by 1, which is the same as a multiply by 2. We're shifting the S2 register, so is that going to be params or varv1? It's not varv1. It looks like it is params. So let's do a params times 2. And then on... So that gives us our shift left too early. All right, let's take this whole thing and multiply that by 2. And again, those shift lefts are too early. So let's do this. This is going to introduce instructions that to reload this pos xi high. But what I want to do is see where the shift left is coming in. So it looks like we're multiplying the whole thing by 2. So let's try that. And that shift left is not in the right place. Let's look at the layout of this global and see if we can tell what it looks like. All right, so we're usually when these are split like this is telling you that this is some kind of struct where each one of these values is being loaded independently. And ooh, this is kind of a bummer. I think what ended up happening, I wanted this really to be a vector, but it looks like it's not. And it seems like it's triples. And I think either Dzik or Roaming mentioned that yesterday, that it looked like triples. We see 490, 4CO, so keep in mind like what the scale of those are. So in the what, right around 1,000, 1,100, something like that, a little higher than that, and then some rotation, and then 350, so somewhere in the 700s, less than 1,000, and then a rotation, and then a rotation. So it does look like these probably are triples. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and then we have padding at the end. And to pack triples like this, I think it needs to just be a sine 16 array. And these will be offsets then in the array. So up here, we're going to change S vector just to a sine 16 array, and then to get these different fields out of it, and this is where the shift is coming in, we need to add 1, and then down here we need to add 2. That still isn't quite right. So the add that's being done is being done outside. So we have an index variable, it looks like. So I'm gonna use this varv1 as the index. Where is varv1 getting set to begin with? Let's look at M2C. And we get the stride by 6 here. That's a good hint. So that varv1 looks like it was never set. Temp S2 is just the masked params. So this is just params. So it's params and then params plus 1 and plus 2. So let's get rid of all of those. That looks like it was just something that GCC did to optimize the loading there. And let's see if that looks right. Still not quite right. It's possible here that we're doing like a params plus plus. Let's get that back. Yeah, let's do it this way. What's strange is the shift happening first. The shift should be done as a part of calculating the appropriate index. Oh, this is going to be... Is it going to be params times 3? Let's try that. These are going to be below. So these do look like struct triples. I'm a little surprised that this would get packed this way. Or no, it's getting... The one is getting added. Does that make sense? I don't think that makes sense. Let's try this. Let's do Params times 3 here. Times equals. And then we could do params plus plus. Yeah, this shift is not what I'm expecting. This does the shift. Add that shift doesn't. Oh, that's the multiply by 3. Yeah. So it could be that these are structs. We should have an off by 1 error here, but here we have 820, again 820, and again 820. And well, yeah, okay. They are structs. Ah, that's weird. So this is a struct of just XYZ values. We'll call them XYR. I didn't think that they would be packed like this. Usually things are packed at power 2 boundaries. All right, let's see if this provided all the appropriate shifts that... Yeah, this did work. So we're shifting by the appropriate amount, adding by the appropriate amount. Okay, just different than I expected. And then our order here looks correct. So I think that top part is correct. Let's check it on the PlayStation. A little better there. Okay, so we start with what looks like an absolute value. If it is an absolute value call, then we will see a function call on the PlayStation where we don't see that on the PSP. In this case, or sorry, PlayStation 1. In this case, there is no absolute value call. It looks like we're taking G entities first. Okay, so the position X and Y, let's create variables for those. I'm going to try 32-bit values. We'll see if that works out. And so usually what happens is position X and position Y are calculated together, and then GCC will come and it knows that these conditions won't hold, and it won't need that Y value unless some invariants are met, and so it won't calculate it until it needs it. But we need it. So we're going to calculate it early. It may be after this check, but maybe not. So what are we looking? Oh, what probably is happening is pause X and pause. No, what is happening here? So looking at the assembly, we're loading the player position X first. And so we need to make sure that that happens. But then we're also loading the self position. Which is offset 2. No, sorry, this is the position X for the player. And then we load the self position, which looks like this. That order seems fine. And something is getting loaded here first. So let's try that again. In this order. Looks like our stack pointer for self is getting loaded first, and I don't know why. Oh, it's taking up player pointer. This happens frequently as well. So let's check the S0 register. I already have an entity pointer down here. Let's see if that is the same variable. S0, yeah, it is. So we're going to take, and is this, no, it's not the player. So we're going to take the player pointer. Sometimes this happens. Not always, but sometimes. And now we're going to reference that directly. Believe it or not, on the PSP, this is an optimization. On the PlayStation, it doesn't make any difference. But when this was being programmed in 1995, programmers would have thought that it made a difference, even though it didn't. And they would have so this macro expands to G entities 0. And so if you're thinking about what does the compiler have to do, or what does the computer have to do to load this, it has to get the address of the G entities array. And so that's going to be baked in at compile time. And then it has to do a lookup, which is adding 0, which again, even here on MetroWorks without an optimizer, that's getting baked in at compile time. And then an offset to that needs to be calculated. And so if you're thinking, I need to read this address, then I need to read the offset, then I need to calculate the offset pointer, and I need to do that here, here, and everywhere else that it's going to be used, you might legitimately think, yeah, I'm going to take a pointer first to avoid 2 lookups, or a lookup and an add, and then do this. But the compiler is smart enough to do that for you. So in this case, it's a waste. All right, so our var S03. This looks like a bool. I'm gonna make these true and false. And so if we're within some bounds, then we're going to check the status of this flag. This flag looks like a possibly am I already falling flag. We can make this a bool. In our case, bools are 32 bits. And so that will be safe and portable. We're never setting that field or that that var, just checking its status. I'm going to make an assumption that it means is the bridge falling. I don't know that for sure. Loading params. Checking a flag that's specified by params. And determining whether that's true or not. That's so EDC is some type of flags. The shift right is weird. I'm gonna look at M2C and see what M2C thinks of this. This is looking at it basically the opposite way. Okay, that makes sense. And probably a better way to think about it. So we're going to take our 1 and shift it by params instead. That probably makes more sense, and how most humans would think about it. Not compiler writers, though, because they are not humans. We know this from empirical evidence. Believe it or not, compiler writers were going to be an enemy in Symphony of the Night, and they ended up being too dangerous to include in the game. Just, it wasn't fair for anybody. So if var S3 is not true here, there's another branch, and it almost looks like it's possibly terminating early. Not quite. There's a load here from the stack. As we get variables cleaned up, those will go away. So it's just noise for now. 67. We're doing this mask and doing a branch. I see. So again, this is an optimization. If this is 1, or if that first bit is set, then we're going to take var S3 and set it to and coincidentally, it is var S3 on the PSP and the PlayStation. Let's make this an and with the rest of them. And that should be fine. Working this out little by little. So I'm not quite sure if this is a switch yet. Let's change it to a switch and see. The jump down here makes me think that it is a switch. However, the way M2C writes it makes me think otherwise. Oh, the self params. Let's think about what's going on. We're setting var v0, and that's getting self params getting set to that, so we can get rid of that almost immediately by setting these as appropriate. And then var s0 is our shift, and that does look like it's getting set. Interestingly, params is params -1 or params minus, sorry, params +1, and the rest of this holds. And so now we can get rid of that block. This will never, if params is 1, it's never going to be 2, and we don't set it at all as we're doing this. So it would make sense that this would be a switch, or at least a if-else. But if we don't have the branch instructions that we expect, then it doesn't matter what it should be. It's not going to be that. Temp A2. It looks like it's this EDC. The shifted params flag is getting taken along. I see. It's getting reassigned here. So every time this is evaluated, it's read again from memory. And I think this can be an or equals. Most of this code is very terse, so thinking in terse ways is probably not the worst idea. Shift left. Again, these are backwards because GCC. Oh, and it's probably this var v0. Let's look at this 82. We have the shifts down there again. So let's try. We're loading the immediate value 1. And then shifting by var s0. And the same thing down here. So GCC knows that params is 2. So it has an invariant here. Params is 2. If params doesn't get set, it knows that it's 2. If params is 2 and subtracts 1, var 0 has to be a 1. And so if var 0 has to be a 1, then it can replace all the places where it was being used as a variable with that constant value, and that saves various instructions along the way, but it makes this harder to decompile. So you have to know that the compiler is going to do that. On the PSP, on the other hand, the compiler doesn't optimize that out, and so we get to see it all for what it actually is. And then, yeah, this is a branch. So this would be an else. Not sure why the PlayStation didn't do that, but again, the PlayStation, oh, because there was a go-to down there. So it would have skipped that anyway. Let's make this a switch and see if that changes anything. So we need the load immediate. So no, we know that it's not a case or switch statement. Sorry. It's getting closer. Let's check the PlayStation. 95, getting there. I think mostly what's going to be missing is variables. And getting those cleaned up. 121. This looks like it's out of order. And we can figure out the order by checking the offsets and seeing what each of these is. Fortunately, because these don't get reordered by the optimizer, we can pretty clearly see where things are going to be. So this is offset C. I'm going to assume offset C is velocity Y because that's what's getting written. Ultimately, this is going to... where is our... it's getting stored to S2, and that's happening, but we're missing the store to 20 and the store to, sorry, stack pointer, loading stack pointer 20, which I think is going to be this draw flags, yeah. And that's all it was. Hey, this is Reality of Gambling. We're decompiling a function related to the bridge in the clock tower of Castlevania Symphony of the Night. This is the trigger, and it also has a lot of the logic, it looks like, for how the bridge pieces fall and ultimately how they collide and the sound effects and everything that get played when they collide. So we're going between the PSP version and the PlayStation version. The code for them is, so far, with the exception of one function at the top, identical. So they're compiled by two different compilers with different compiler settings. The PlayStation is GCC with standard optimization. The PSP is MetroWorks or Code Warrior with no optimization. And they both have some advantages, and having both of them at the same time means we have two different data points for how to solve that compilation. 150, there is a load here of, this is the way that entity IDs work on the PSP. Often entity IDs, instead of being hard-coded values, are global. They're not even constant, they're just globals. And the easiest thing to do right now probably is to make an EID macro for that. I don't have any of those globals set up, so we'll just make a difference for the PlayStation. So we're going to call this EID 17, and on the PlayStation that's going to be this guy, which is an extern S32. And then on PSP, sorry, PlayStation, EID 17 is just going to be the hex value 17. Long code into a short one. I don't know if that's how I would phrase it. We're trying to take machine code and turn it back to C code, because people usually don't want to read machine code. Sometimes they do. So that's getting pretty close. So we have the machine code from the game that's from the disk in this column, and we have the machine code that we're generating from our C code here in this column. We want those to mostly be the same. They're not going to be identical because of some symbol values, but we should get most of the instructions to be the same. Let's take this, check it on PlayStation again. I'm still at 95%. And so this number, by the time we're done with the function, this number up here should be 99.9 something, hopefully. And that'll be enough to take this to a C file. Just use ChatGPT. There's legal implications to that I don't want to get into. I can if you're interested to why I don't use ChatGPT. ChatGPT can do this, and so we have other tools. So this is M2C. This will give us some C. If we fed everything that we've decompiled into an LLM and then asked it to go and do it for the remainder of the code, it actually might do a pretty good job if it wasn't terribly illegal and would get you put into jail. M2C does a reasonable job as well, but this does not compile back to the same machine code, and that's what we need. The thing about legality has to do with, at least in the US, copyright law, and if it's a machine translation as opposed to a human translation, it is not protected. It is not a protected work. It's called a mechanical transformation, and a mechanical transformation is not protected under fair use, or you don't own the copyright to the end result. So we need to make sure that whatever we're producing, so this code as it exists here is something that I created, and I did it in front of anybody. You can go back and watch yesterday's stream and today's stream. This is something that I wrote. This is not any game company's code. It wouldn't exist were it not for me doing this right now. So I own the copyright to all of this code. Nobody can come after me and say, this is my code, because it's not their code, or tell me it's their code because it's my code. I wrote it. Something like this, though, that was automatically generated, that is not my code. And it was automatically generated from this middle column, which is not my code. So I don't have any right to claim that is anything but the game company's code, because it's a mechanical transformation. So if we extend that to other programs like chatbots, LLMs, anything that they produce one by looking at other people's copyrighted works that they may or may not have permission to use, but also it's not a human that's doing the transformation. It's a mechanical transformation, not protected by copyright. And illegal is probably the wrong word, but it's a safe enough word to know that I could be in legal jeopardy by using it. And I don't want to put myself into legal jeopardy. There are definitely people, and there's actually in various decomp communities, there's a lot of discussion around using LLMs to do this, and a lot of people do use LLMs. I am risk averse, and so I try to stay away from it. I'm not a lawyer. I'm not your lawyer. So take with that what you will. I do have a reasonable amount of, done a reasonable amount of research into the work that EFF and others have done, Video Game History Foundation, and so I'm pretty comfortable in my position. So what I'm going to do now is I need to get rid of some of the stack space that's being used. We have 2 additional variables on the stack. And so to do that, I'm going to highlight the register. One of the nice features of how MetroWorks compiles when it doesn't have optimization on, it usually assigns a variable 1 register and uses that throughout the program. And so if I can come down here and find, for example, it's using S3, my program is using S6, or my implementation is using S6. So as long as those are used the same way everywhere, they're probably the same thing. Here on 110, let's go back up actually. Give me back my S3 and S6. This will tell me on 63 that var S3 is probably what was being used up there as well. And so when we do this, and this may be using this var S3 variable, and var S3 is not a very good name, but and it's possible that this is an ephemeral variable as well, or ephemeral register, and not actually using that, but for right now this works, and so I'm going to keep it. It does look like this is backwards. And if it needs to change, excuse me, then we'll change it. So now we did get S3. So now we want to go through and make sure everywhere S3 is used on the left, S3 is used on the right as well. Hey, Dizek, good to have you back. .111, we're going to make all those var S3s as well, and that should hopefully get rid of one of the variables. Temp S3, good name. Get rid of some of these casts. Check it one more time. Anything else? Here we have another one on 132. That looks like I use params, but it looks like it's var S3 here. Oh, 158, I didn't notice this. We do have some noise down here. It looks like out of order. All right, so we have that one done, and we got rid of a couple variables along the way. Maybe just temp S3. var A0 is gone, so it looks like var S0 might be our last. And my guess is that this is also var. No, it can't be var S3. So it needs to be something else, but I don't know what. Let's go down to 73 over here and see what we got. So it's S2. Ours is S4. S2 is up on 66. Params? Oh, that's just params. All right. It looks like params probably should be unsigned, which does make, it is unsigned. All right, let's do a plus equals then. See if that changes it. Pos X and pos Y. Those need to be unsigned? That's a little strange. Yeah. So if that was unsigned, pos X is unsigned, then the negation wouldn't be possible. That's weird. That pos Y is unsigned. Var S0 is gone now. $97. The things that I need to look out for are greater than equals. So let's look for those. Let's see if any of those slipped in. That should help with the A0 versus V1, or A0, yeah, V1, V0 mix-ups. Everything else looks fine. I don't remember any greater than equals, but or less than equals. It does happen though. I'm guessing this will work on the PlayStation. So we're 99.77. When we look at these symbol differences, we'll see that the low part is a +2, which means it's the same. The high part is the disassembler looking at how this register is being used. And this one's actually interesting, and I would like to look. So SPIM has an algorithm for this, but I'd like to understand this more. So this high bits, so the 8018 is what is the constant on this instruction. It's being loaded into the upper, 16 bits, the upper 16 bits of the at register. The at register and the A0 register are being added and stored into at. I'm not sure what the purpose of that is at the moment. But then a combination of the low bits from here and the high bits from at are being used to load V1. So this triple of instructions tells you, combining those will tell you what the address is. Likewise, the double here of these instructions, and this one's a little more obvious. We're going to load the high bits into A0, and then we're going to load the low bits into A0, and then we have our full address, because we can only load MIPS 32, actually any MIPS as far as I except for MIPS 16. MIPS 32 or MIPS 64, you can only load 16 bits of constant data at a time, and so you need 2 instructions to load a 32-bit address, or 4 instructions to load a 64-bit address. So I'm a little curious about this construction. This other one down here is a little more obvious. The reason that I want to know about these things, I've mentioned MIPS match before. It's something that looks at the machine code assembly, and when you have globals like this in the machine code, you have to mask those out in order to try to find a duplicate function in another overlay or another file. Because the globals in that file are going to be at slightly different addresses. They might be shifted. It might be loaded into a very different location in memory. And so you mask all those out, and then what you're left with is matching basically everything else. If you can identify what those instructions are and where the high and low parts of the address are coming from, and you know what that address is in the original that you were looking for, you can see what the symbol name for that is. And if you know what the symbol name for that is, you can suggest that symbol name for the thing that you're trying to match as well. And Project Oblivion does this in some of his make configuration tools, but he does it by looking at the text assembly. And when you're looking at the text assembly, the work has been done for you already. I want to try to do it by just looking at the machine code binary, because getting to that text assembly is expensive, and you don't always have it available. Anyway, that's what was happening there. And same thing here. It's going to be probably F20 plus 6 or F24 plus 2. Okay, that's fine. Different symbol names. No issues, no issues. So I do think the PlayStation version works. Let's take the PlayStation. No, let's fix the last remaining thing on the PSP. We're close. We just have those register issues down below. My son says, where was that? It's around line 96. When my wife's favorite sports teams are playing, that they have end zone issues, end zone struggles. All right, so 97, we're up here. So normally I would say that this should be just a greater than. I'm going to change it to a greater, so greater than 3. That includes 4. So it's 4 and above. So I'm going to change this to greater or equal to 4. Usually I wouldn't put it this way, but in this case, it makes things much worse. But see how it changed the at register to V1. And back to at when we do that. So changing the comparator, even though we think of it as being the same thing, ends up being slightly different. Break bridge possibly does. That's the issue. Let's go look at break bridge. No, it's not the issue. I thought possibly break bridge. I see what the issue is. I thought break bridge might not have taken an argument. If it didn't take an argument, do we get the right thing? We're not getting the right thing in the A0 register. So let's look at the adjacent statements. We're breaking the bridge and then immediately incrementing the pose. We want the old pose value before the increment, but we can do that with a post decrement or a post increment. Ooh, I was really hoping that was going to be it. Let's try plus equals 1. Give me 1 second. Apologies. What I was saying is I have to go. So we're not going to figure this out today. I'll be back tomorrow. We'll figure it out then. And hopefully it's something relatively mundane, but let's try one thing. Yeah, we got an extra sign extension there. Something funny's going on. We'll figure it out. But that's all I got. Adios.